So this video is going to cover chapter 15 of geometry. It's going to go from 15.1 to 15.7, and we're going to focus on the geometric proof and what it is and how to do it. And so by the end of this video you should know a general basic knowledge of the geometric proof. So we're going to start with some vocab. So postulates are going to be a collection of statements regarded as obviously true, so you can use them for your proofs. Theorems are sort of similar. They're geometric discoveries that followed logically from postulates and previously verified conjectures, so you can also use them in your proofs. And then the deductive system is a set of premises and a set of logical rules. And this is going to be very important in your proofs. So the inductive reasoning process goes from observations to generalizations. So, for example, you could observe a whole different bunch of angle measures in triangles and then conclude that all triangles have angle measures that add up to 180 degrees. The deductive reasoning process is the opposite. So you have facts accepted as true, and you use those to then conclude the logical consequences. So now I'm going to talk about geometric proofs. So a proof in geometry consists of a sequence of statements, each supported by a reason that starts with a given set of premises and leads to a valid conclusion. And a reason for a statement can come from the set of given premises or from one of the other four types of premises, which can be definitions, postulates, properties of algebra, equality or congruence, or previously proven theorems. And all of these things can be found in your textbook. So now I'm going to go through an example of a geometric proof. So the conjecture we're trying to prove is that the angle bisector of the vertex angle of an isosceles triangle is also a median to the base. So what we're given is the isosceles triangle ABC, which you can see here, with segment AC congruent to segment BC, so these two are congruent, and with CD an angle bisector of vertex angle C. So these are congruent angles. And then what we're showing is that CD is also a median to the base. So we're going to do a two-column proof. We're going to start out with the fact that segment AC is congruent to segment BC, and that's a given. That's a premise. And then we're going to say that CD is angle bisector of C, and that's also a given. And then we can say that angle 1 is congruent to angle 2 by the definition of angle bisector. And then we can say that means that, and then segment CD is equal to segment CD because of the reflexive property of congruence. And then we can say that triangle ADC is going to be congruent to triangle BDC by the SAS congruence postulate. And then we can go on to say that segment AD is going to be congruent to segment BD by the definition of congruent triangles. And also CP, CTC, that congruent parts of congruent triangles are congruent. So that's what you really want to focus on here. And then we can say that D is a midpoint of AB, segment AB, by the definition of midpoint. And then our final step, therefore, CD is a median. And that's by the definition of a median. So that's a geometric proof. You can see you use a bunch of different postulates to prove a geometric conjecture.